The SensiTouch is a glove-based device designed for patients with damaged nerve endings and functions to monitor crucial tactile senses. Currently, the National Institute of Neurological Disorders and Strokes report that nearly 20 million people in the United States suffer from damaged nerve endings. There are approximately 29 million people in the United States with diabetes, and around 60 to 70% of this population experience some form of damaged nerve endings. Sensory nerve damage affecting larger sensory fibers that register vibration and light touch can affect reflexes and coordination. Damage to smaller sensory fibers, which transmit pain and temperature sensations, can interfere with a patient's ability to feel pain or changes in temperature. For this reason, we have designed the SensiTouch for this population to both prevent injuries and to provide sensory information to the user that they wouldn't otherwise have. The device was originally designed to include 3 sensors of 2 types on 3 of the fingertips of the glove in order to detect temperature, pressure, and surface roughness. If the sensors detect a value that exceeds the predefined safety threshold, the device will provide a visual and auditory signal to alert the user to the danger and also to provide general surrounding sensory information. For the temperature indication, the device uses a LilyPad temperature sensor to detect when a value is either below or above the predefined threshold and to provide an alert with both an LED and a buzzer. Additionally, the design contains a small LCD display so that the user may know the temperature at all times. For the pressure indication, the device uses a force sensing resistor to detect either when the user is in contact with a surface or when there is too much pressure being applied and alerts the user with both an LED and a buzzer. For the surface roughness indication, the device uses a force sensing resistor to detect if a surface is either smooth, moderate, or rough, and it was designed to utilize a multicolor LED to notify the user. We originally began designing and constructing the SensiTouch with the intention of incorporating an Arduino into the glove-based design. In the initial stage of experimenting with the temperature sensor, we struggled with overcoming the amount of noise in the breadboard circuit, thus preventing an accurate readout of the temperature value. We then decided to replace the Arduino with LilyPad components, which is a wearable technology in which large connecting pads allow various sensors and wires to be sewn into clothing while maintaining inputs, outputs, and power. By using the LilyPad components, the SensiTouch would be more mobile, easier to manage for the user, and a more seamless design. While constructing the device with the LilyPad components, we encountered the following unforeseen difficulties. First, similar to issues surrounding the noise level with the Arduino, we are unable to acquire accurate readouts. Due to the noise interference, the voltage difference was affected as a result of the non-stable ground reference, thus affecting both the temperature and pressure sensors. In the end, we determined that the noise was caused by the glove's conductive material properties, thus causing us to relocate the SensiTouch components onto a strip of felt to provide a better simulation. In the end, we were able to use wire coating to protect the wire and allow us to complete the design on the glove. Due to the discrepancies between LabVIEW and LilyPad software, we were unable to compile parts of the code, most affecting the LCD display. The LCD display worked independently when tested on the Arduino software, but was unable to be compiled into LabVIEW. However, we were able to modify various aspects of the LabVIEW code in order to integrate the LilyPad sensors. We determined that the LilyPad technology was not yet meant for complex designs such as the SensiTouch. From examples online, we concluded that the LilyPad is more meant for at-home activities involving one sensor at most, and for this reason, we would take future steps to use a more advanced wearable technology. As a result of our troubleshooting, we are unable to complete the surface roughness aspect of the device. However, we are ultimately able to solve the noise level and conductive issues by using wire wrapping wire, which is a thin and insulated, unlike the conductive thread. The insulation ensures that the material of the glove cannot interfere with the actual circuit. By using the wire wrapping wire, we are able to once again relocate the sensors back to the glove and minimize the noise to such an extent that we yielded accurate results. We would like to thank Dr. Merrick, Mingyue, and Yu Hao for the assistance and support throughout the design process and various iterations of the SensiTouch. Throughout the process, we've learned how to troubleshoot through various issues and modify design to fit specific needs. For future steps, we would like to complete the surface roughness aspect as well as integrate a better wearable technology to make this device as accessible to an everyday user as possible.
because I want to get it where it's green. Shake it, take it over.
She does have a script. Oh, you do have. We do have a script. Okay, okay, yeah. But you should go with this one seriously. Yeah. We do have a script. Okay, yeah, because it is so. Share it.